Okay guys, today I just wanted to do a trial lesson which will be our basis for all our lessons moving forward. I don't have much resources for now, so for now I'll just be using a piece of paper and my laptop, as you can see, for past papers, and we will take it from there. Obviously, as we move on, I will try and get a blackboard which I can stick on one of those stick-on boards which you can stick on the wall and write on. So I'll get that and we'll take it from there. So for now, I need you guys to criticize, to judge, but obviously everything has to be positive, guys, and constructive. Okay, tell me where I can step up my game, what I can do, and so on. So for now, I'm just gonna do one question, which is from an Eastern Cape paper one, from November. So it's last year's paper. It's from a few months ago because last year isn't that far away. Yeah. So yeah. So I'll be doing question two. You can actually get this paper from the internet, guys. It's paper one from the Eastern Cape paper. So it's question two. So question 2.1 is asking us to solve for x, and we're given x squared as a question is equals to negative 5x. So for something like this, I always tell my students that we usually take all the variables and put them on one side. So we'll take this over, and whenever we take something over, the equals to sign, it changes its sign. So if this is negative, if you take it over, it becomes positive. So this becomes positive 5x, and if you take that over, obviously you're left with nothing here, and 0 symbolizes nothing. Then we factorize this using something called the removal of a common factor, and that common factor here being the x. So if we take away x here, you're left with x plus 5, which equals to 0. So we're left with 0. Then from this you can say x is equal to 0 or x plus 5 is equal to 0. For this side here, we already have a definition of x, which is x is equal to 0. But for this side here, we don't have an actual definition of x, but we have a definition for x plus 5. So we need to do something with the 5 in order for us to have an answer which says x is equal to. So we'll take the 5 over, and this becomes negative 5. So we have x is equal to 0 or x is equal to negative 5. It can be both or either of these two. So you can actually go test this out and see if it actually works. So you can go and put 0 here and then put 0 here and see if you get the same answer for both sides. Or you can take this negative 5 and put negative 5 there and see what you get, and then take the negative 5 and put it there and see what you get. And if you get the same thing for both, that means your answer is correct. Now question 2.2, we're given v is equal to 4 over 3 pi r to the power 3 r to the power 3. Okay, we have capital letter R and we have small letter r. Then you have to solve. Then they're asking us to make r the subject of the formula. Okay, so if you're making r the subject of the formula, and be careful, it's just the small letter r, not the other r. So we need to take everything from this side and bring it over to the side, leaving only r here. So we'll do that. So the first thing we'll take over is basically whatever is closest to the side. Yeah, it's like when you're working, right? Let's say you want to move something from point. Let's say we want to move something from point A to Z. Okay. So obviously, before we get to point A, we need to get rid of whatever it is that's between A and Z. And it would be very energy consuming to leave something here, like an obstacle here, and go remove something here just to get to A. So you basically have to remove everything that's here in order for us to get there. So what I mean by that is obviously you'll start with whatever is closest or whatever is much easier to take over to the other side, or whatever is closest to the side first before we can actually try and do anything with this here. So we'll move 4 over 3 over. So if you move 4 over 3 over, okay, if there's nothing between variables, then that usually means it's multiplication. So the 4 over 3 is being multiplied to pi, and the pi is being multiplied to this entire bracket. Okay, so if you take this over, you have to take it over as division since it's multiplication this side. So it becomes 4 over 3, and that pi, you can also take that pi over, then you can leave the brackets, so you have that. Okay. Okay, here it's like dividing a fraction with another fraction, so we can handle that as well. So we'll have 4 pi here, and this 3 here will go. I'm just dividing these two things, and if you divide these two things, you're going to end up with this. If you simplify this division here, then you're left with r to the power 3 minus r to the power 3. Then our aim is to get this, so we have to take that over, and this has a positive in front of it, so if you take it over, it becomes negative. Then you're left with negative r to the power 3. Okay. So what we can do now is you can make this positive. How do you make this positive? We can either multiply the entire thing by -1. Now whatever it is you do to the side here, you have to do to the other side as well. So if you multiply this by -1, we'll end up with something like this. Then this side will be positive. Now since this is cube, we need to do the opposite of cubing, which is the cube rooting. So we will cube root this. Okay, leaving us with that. So that's our answer. Now on to question 2.3, which says solve for x if we have 2 into 4 minus 3x, and we have a less than and equals to, you have a greater than and equals to 20. Okay, right hand side is greater than and equals to, so we have 2 into 4 minus 3x greater than and equals to 20. Okay, then they want us to solve for x. Okay, so we have this. Okay, then want to solve for x. So it will be extremely difficult for us to start with whatever is in brackets, so we'll start with whatever is easier for us to take over, and in this case here it's the 2. Because everything else is locked in that bracket, so you have to take the 2 over, so it becomes 2 divided by becomes 20 divided by 2, since This 2 here, and the bracket is separated by a dot, which is multiplication. Obviously it's invisible, you cannot see it. So we'll take the 2 over, it's multiplication, take it over, it becomes division. As we can see, the division sign here. Then we have 20 divided by 2, which is 10. So we have 4 minus 3x is greater than or equals to 10. There's no need for the bracket now because there's nothing outside. But okay, it's fine, I'll leave it there. So we have that 4, which has a plus in front of it. So if you take it over, it becomes negative. Okay, so we have 10 minus 4 minus 3x. I'll just repeat that there's no need for the bracket anymore. So there wasn't any need for me to put it, but it's not wrong if it's there, but there's no need for it. Okay, now we know there's plus here, so if you take it over the bracket, the greater than or equals to sign, it becomes negative. Guys, remember, inequality signs can be treated as just equal to signs, but at the back of your mind you should know that it is an inequality sign, because there's just 1 or 2 rules that I added to to the normal rules of solving for x. Like in this case here, if it's negative and if you want to solve for x, then the sign changes. In this case here, our aim is to solve for x, but what do we have here? We have negative 3x. So how do we make this side x? By dividing this by negative 3. Now whatever we do to this side here, obviously you have to do to the other side, negative 3. Okay, let me just simplify this first. This would have been what? 6 over negative 3, and this side here will just be x. But because we're dividing by a negative here, because we divided by a negative throughout, so what changes? That's the direction of this has to change. So instead of this becoming greater than or equals to, it becomes less than and equals to. So our answer in this case here would have been x is less than and equals to 6 over negative 3, which is negative 2. Okay, then on to question 2.4, which is our second last question. So we are asked to solve for the following. Equations. Simultaneously. For A and B. Okay, so this is a question. Solve for the following equations simultaneously for A and B. And our two equations are A plus B is equals to 12. And we have 4A plus 2B is equals to 44. So we have two equations which we can label. You can label this as 1 and label this as 2. Okay, and we are asked to solve. Okay, the nice thing about these two is this is already in the form of A plus B, so you can easily solve for A or solve for. So I'll take equation 1 and I will solve for A or B, or write this in terms of A or B. So I'll choose to write in the form of A is equals to, so it will be A is equals to 12 minus, since it's plus B here, take B over, it becomes minus B, and I'll call this my equation 3. Okay, then I'll say substitute 3 into 2. Okay, this substitute means I'm going to take the equation 3, my new equation, and go plug it in here. Then once I plug it in here, I'll have the entire equation in the form of B, or with respect to B. So what happens is, where I see A, I substitute A with 12 minus B. So this becomes 12 minus B plus 2B is equals to 44. Then I can distribute this 4. And this becomes 4 times 12, which is 48, minus 4b plus 12b is equals to 44. Okay, so we have minus 4b plus 2b, which becomes minus 2b. So we have 48 minus 2b, which equals to 44. Then take the 48 over, because we just want to leave the variables on one side. But in this case, yeah, it's nice because you only have only one term with a variable, which is the minus 2b. So you take the 48 over, it becomes 44. 48 is positive this side, take it over, it becomes negative 48, which then becomes 44 minus 48, which becomes minus 4. So we have minus 2b is equal to minus 4. We just want to have b on the side here, so you can divide this by minus 2 and divide this by minus 2, so we're left with b is equals to what? 2. Okay, so b is equals to 2. Then you already have one variable. Now our aim is to get a. Okay, but the nice thing is we already have an equation which will give us a if we have b, and we do have b. So our a is equals to 12 minus b, and we know our b is what? 2. So our a is 10. So we have a is equals to 10, and we have b is equals to 2. Now on to question 2.5. Okay, so this is a long question. It's one of those long questions. So we have SIPO is 7 times older than his son. What a coincidence, because it's Father's Day today. His son. Okay, then we are told in 25 years he will be, in 25 years time, he will be twice his son's age. Then we are asked to calculate the son's present age. Of course, I'll summarize this, it's a bit too long, but you get the gist of the question. Okay, so in cases like this, we always introduce a variable. So the most common variable to introduce would be your x. Okay, sorry, this is a question. So okay, clear, right? Yeah, you can actually pause the video if you cannot see the question properly and look at it. Okay, so what can we do is we can make one of their ages a variable. So we can just say SIPO's age and call that x. Or let's say it's much easier to do like this. Let's say son's age. Son's age is x. Then if SIPO is 7 times older than his son, that means SIPO's age would be what? Would be 7x, 7 times x. Okay, then we are told in 25 years time SIPO will be twice his son's age. So see, his son's age right now is x, but in 25 years his son's age would be what? In 25 years. Okay, let me just put in 25 years. His son's age should be what? X plus 25, because it should be 25 years later, right? In 25 years, son's age should be that. Okay, then in 25 years time, SIPO's age should be what? Whatever his age is now plus what, plus 25. So it should be 7x plus 25, right? But you know, after 25 years, Sipo should be twice his son's age. So if his son's age after 25 years is x, is that, and we know that Sipo's age is 7x plus 25. We know that Sipo should be twice his son's age. So his age in 25 years time should be twice this. So that should be that. Then we have to solve for x. So this is a formula that we have generated using that statement. Then from this we can solve for x. So we can distribute that. So this will be 2x plus 50 is equal to 7x plus 25. Okay. Then we can solve for x. Then we can take all the variables and put them aside here. Take all numbers and put them that side there. So this becomes negative 25 and this becomes negative 5x, and then you can divide this by negative 5 both sides. Okay, dividing both, this becomes 5, x is equals to 5, and we know that his son's age is x, so his son is 5 years right now.